Alright, solutions to worksheet 12.2. Let's go. Question 1. First of all, see my clicker here again. Click, 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 click. Look at this part. Okay, the axis says time. So we have period. We do not have wavelength. Right? So the period is actually one complete cycle, 20 seconds. But the question asks us for wavelength. We are not able to observe the wavelength from this graph. So what do we do? Okay, V equals to F lambda. Okay, we want to find the wavelength lambda. Okay, that will be equals to V over F. Speed is given to us. What's the value? 5 meters per second. Okay, the frequency we do not know. However, we know that the period is equals to 20 seconds, right? Okay, we know that the period is 20 seconds. And we know that frequency is equals to 1 over period. 1 divided by 20, what is the value? 0.05 Hertz. Frequency is 0.05 Hertz. Substitute this value into the formula here, 0.05. Okay, and we should be able to get the answer of, okay, let me check. 5 divided by 0.05, 100 meters. Okay, and hence the answer D. Okay, answer D. Right? Let's move on. Okay, a circular wave is reflected upon a surface. Okay, the answer obviously has to be A because there's no other disturbance, so whatever is being reflected has to look the same as the original wave. The wavelength between the two wavefronts, okay, this is the wavelength, must be the same here. Okay, wavelength must be the same. And only A shows reflection. D could be a possible answer, but it doesn't show reflection. And hence only A. Move on. Okay, this one is similar to the previous worksheet, which symbols represent amplitude and frequency. Again, time. We can observe period. Alright? So, amplitude has to be, okay, this whole thing is X, but we do not need X, we only need half of it to form the amplitude. So, amplitude has to be half of X. It's either C or D. What about the frequency? As mentioned, axis can only give us, or the axis tells us that we can only observe period. So how to find frequency? Same thing. Frequency is frequency is 1 over period, right? We know this. So back to here, we know that the period is Z. Okay, so the frequency has to be 1 over Z, which is the period, and hence answer D. Why answer D? Or because there is no such option as 1 over Z, 1 over Z. However, we do know that 2y is the same as Z, right? 2 times of y is the same as Z. So D is also the correct answer. 1 over Z. Z is also the same as 2y. Hence answer D. Right? Because here y is half the period. 2 times of y will be the full period. Okay, let's move on. Okay, 4. The diagram shows waves traveling into shallower water. The wavelength is reduced, frequency not affected. So A and C immediately out. And how is velocity related to the wavelength? Both must be reduced. Okay, when you move into shallow water, wavelength reduce, velocity will also decrease. Answer D. Same thing if your water moves to deeper water, wavelength will increase, and at the same time velocity will also increase. They move in the same direction. One increase, the other one increase. One decrease, the other one decrease. Let's move on. Alright, this one, nothing much. V equals to F lambda again. Okay, just to take note, mega is 10 to the power of 6. Okay, so let me show you the working. Okay, V equals to F lambda. We need to find wavelength, which is lambda. Okay, do note that as I write my solution, right, I always write down formula, okay, like this. Then I show the substitution. Speed is 3 times 10 to the power of 8 as given over the frequency. Frequency is 100 megahertz, right? 100 mega times 10 to the power of 6. Okay, check this on your calculator. You should end up with the value of C. Okay, 3 meters exactly. Move on. This object Z is floating on a water surface. The frequency of the wave is 0.25 Hertz. Okay, where is the position of the wave 4 seconds later? Now, can you please highlight this? The frequency of the wave is 0.25 Hertz. Now, what is frequency? Frequency is the number of complete oscillations produced in 1 second. So if the frequency is 0.25, it tells us that in 1 second, 0.25, or in other words, 1/4 of a wave is completed. So 4 seconds later, we would see 1 complete wave. So is the object going to move to D or A? Neither. It will stay at B. 1 complete wave is going to move down and come up to the same position B. Why doesn't it move to A or D? We covered in the notes. The particle does not move with the wave. It only bobbles up and down. And why does it go back to its original position after 1 round? Precisely because the frequency is 0.25 Hz. After 4 seconds, it completes 1 complete bubble down, up to the same position. Let's move on. Okay, yada yada. From the graph, determine the wave's amplitude, 6.25. Many students are tricked. Let's look at this. Now, why is it 6.25, not 6? Because 1, 2, 3, 4 units represent 5 meters. So 6 units represent, go and do a calculation, it should be 6.25 meters. Wavelength of the wave. Obviously, we shouldn't look at graph 2. Because graph 2, horizontal axis is in time. To find the wavelength, we look at the first graph, where the axis is in distance. So 1 complete wave in 20 meters. Wavelength will be 20 meters. Okay, as shown. Frequency. Frequency can be only obtained using period. And period can be obtained from graph 2. Okay, I will not refer you back and forth, I think it's a bit dizzy. So, if you observe properly from graph 2, the period is 0.2 seconds. And frequency, use the formula F equals to 1 over T. Show all the steps, the formula, the substitution of this value, 0.2, and then final answer to be awarded the full marks, 5.0 Hertz. Speed, okay, F lambda, frequency has been found, lambda has been found, and hence 100 meters per second. Alright, question 8. Now, do note, this has not been highlighted in your notes, this has not been highlighted in your worksheet, go and highlight it. The wave makes 8 complete oscillations in 2 seconds. This is a very, very, very important information. It is actually derived from one of the definitions. 8 complete oscillations in 2 seconds, which actually means 4 complete oscillations in 1 second, right? Isn't this the frequency? Okay. Frequency measures the number of complete oscillations in 1 second. So, the frequency happens to be 4 Hertz. Okay, let's go back. That's how I got this step. Okay, the very first step. How do I know the frequency? 8 divided by 2. And hence I get 4 Hertz, or 4 complete oscillations in 1 second. This is a very tricky question, and O-level likes to ask this question, so please take note. Okay, this is part B. The speed of the wave is 0.8 meters per second. Calculate wavelength. Okay, apply formula. I think there's nothing much to discuss here. Okay, just substitute values. On the figure above, part A, mark the direction in which the hand must move to make a transverse wave. A transverse wave is defined as a wave that travels in the direction perpendicular to the direction of vibration. So if the wave travels this direction, the oscillation the vibration must move in the perpendicular direction, which is up and down. Okay, this direction is perpendicular to this direction, right? And hence, this weight arrow is the answer. Let's move on. Okay, this is the, we'll come back to this. Okay, answer as shown. Do take note, wavelength is written here, 5 millimeters. Millimeters is times 10 to the power of -3. Alright? And that explains why I have the wavelength here, 5 times 10 to the power of -3 for region A. Okay, frequency, we do not know. Speed is given in the question, so we calculate and we end up with 50 Hz for the frequency of the wave in region A. For region B, similarly. Okay, which region represents shallower region? Region A. Okay. Now, the last one, sketch the approximate direction of the waves, the refracted rays after passing through the boundary. Okay, because A is a shallower region, the lines, the wave fronts, okay, should be closer to each other. Okay, the wavelength should be shorter as compared to this. And do note on this particular question, it is drawn exactly to scale. Right, so your drawing must be to scale. Okay, move on. Okay, 4-mark question in question 10. Okay, describe the depth of the water, making reference to wavelength, frequency, and speed. Okay, there are 3 indications as the wave moves from the left to the right. These are the 4 options. You must get, not 4 options, these are the 4 answers. You must get all of them correct to be awarded the full marks. Okay, the description, what happens to wavelength, what happens to speed, what happens to frequency. Okay, let's move on. 11. Okay, what is the velocity at point Z? Okay, V equals to F lambda again. Okay, I shall not go through too much. Alright, to be able to solve this question, we need frequency first, because over at point Z we need to apply the formula V equals to F lambda. The frequency, as you know, for both sides doesn't change, right? Because no matter whether the water travels from deep water to shallow water or vice versa, the frequency doesn't change. So we must make use of the information here. The wavelength is 3 cm. The speed is 12 cm per second. With that wavelength and speed, we can calculate the frequency. Okay, frequency is V over wavelength. The speed is 12, right? Okay. The wavelength is, what is that? 3, right? So, frequency is 4 Hz. Okay, using this same value for frequency, 4 Hz, we now go to position Z. S. Okay, the wavelength now becomes 1.5, but the frequency is still 4. So, with that, we want to find the velocity, F lambda. Frequency is still 4, wavelength is now 1.5. So the answer of 6 centimeters per second for this question. And hence the answer B. Okay, let's move on. Okay, this question 12 is drawn to scale. What is the wavelength of the ripple? All these are the wavefronts, and the distance between each wavefront to the next is the wavelength. So this question is drawn to scale. Take a ruler, measure from this to this. It should measure exactly 0.01 meters. Okay, or in other words, you should actually measure 1 cm. Okay, but because the question requires you to enter your answer in meters, so you have to convert to 0.01 meters. Okay, calculate the speed. Same thing again. If the time taken for one complete wave to produce is 2 seconds, this information very important. This is just period. Period is the time taken for one complete wave to be produced. So, 2 seconds to produce one complete wave, that is the period. Okay, with that, you find frequency, and with that, using the wavelength calculated above here